complex procedures about normal force. Ne? So when there is no Fa component, ne? So if we have a block here, if we have a block here, and therefore we apply a force, ne? And we have block 2, and we apply a force, but on a certain angle, ne? So when we apply a force on a certain angle, we are going to produce two components, which is Fax and what? And Fay. Ne? But when we apply a force here, ne, there is no angle. Ne? There is no angle, meaning that we are not going to produce Fax or Fay. Ne? So meaning here, we are not going to produce Fa components. We only produce Fa components. Note this. We only produce Fa components when we apply a force on a certain angle. Ne? Let us study case number 1. Ne? We have learned that on a horizontal surface, normal force is equal to what? Fg. On a horizontal surface, normal force is equal to Fg. Ne? So the formula for Fg is equal to mg, meaning that normal force is equal to what? Mass times gravity. But what? Normal force is equal to mass times gravity. Ne? Inclined surface, case number 2. Ne? We have learned that on an inclined surface, normal force is equal to what? Is equal to Fg perpendicular. We have learned that normal force is equal to Fg perpendicular, ne? But different direction. Ne? So, meaning that normal force is equal to what? Mg cos theta. The reason why normal force is equal to mg cos theta is because of the formula for Fg perpendicular is equal to what? Mg cos theta. So normal force is going to take this formula for Fg perpendicular. Case 1 and case 2 is easy. Ne? Let us now move to case number 4. Ne? So when we apply a force on a certain angle, we are going to produce two things. Which is Fay and what? And we are going to produce Fax. These are what? Fa components. Not forgetting that we are dealing with horizontal surface. Ne? So horizontal surface, it means that we have to include our Fg, gravitational force. Gravitational force is pulling this object downwards. And also we have what? We have normal force. We have normal force. Ne? Meaning that normal force plus Fay is equals to what? Fg. Ne? Meaning that normal force plus Fay is equals to what? Fg. Ne? So we can solve this further. Ne? Meaning that normal force is equals to what? Fg. When we transpose Fay, it changes sign. It becomes Fay. Ne? So case number 3, it means that normal force is equal to what? Fg minus Fay. We can break this further. When we break this further, Mg is equal to Mg minus what? Minus Fa sine theta. Ne? Take your time to master case number 3. Let us now move to case number 4. So force applied is applied on a certain angle, but what? Downwards. Ne? Downwards. Unlike case 3. Ne? Downwards. Ne? So let us draw our free body diagram. Ne? Because of Fa is applied what? On a downwards direction. So instead of drawing Fay upwards, Fay it has to be what? It has to be, instead of drawing Fay upwards, Fay is going to be downwards. Ne? So it's Fay, Fax. Ne? Fax. Not forgetting that we are dealing with horizontal surface, we have to also include our normal force. And also we have to include our what? Fg. Ne? So now normal force is equals to what? Fg plus Fay. So now normal force is equals to Fg plus Fay. We can solve this further. So the formula for Fg is the product of mass and gravity plus the formula for Fay is force applied multiplied by sine theta. Ne? Sine theta. So when you are given, let us say 20 degrees, it means you are going to substitute 20. If you are given 30, you are going to substitute 30. 40, you are going to substitute 40. Ne? So theta, it represents that. Note this, theta, it represents what? Angle. Ne? So master case number 1, master case number 2, also master case number 3, and also master case number 4. Note this, always when dealing with forces, you have to start by drawing what? Free body diagram in order to what? To represent your forces.